Assalamu alaikum and welcome back to part 2 for chapter number 11, where we are actually going to discuss the random access files, or actually the binary files, which are the second component in chapter number 11. For those who have still not gone through part 1, this part is useful only if you have gone through the part 1. The link is with the description of this video. So we are talking about chapter number 11 at present, and the article is 11.5, which is actually the random access file. And in this random access file, we are going to discuss that why we actually go with this random access files, or actually the binary files over there. Just a small recap of what we have done in the part 1 over there. If you remember it, in part 1, we had a very small file created over there based on the modes that were available, and that were these modes over there. Whenever you were opening a file based on the file pointer, and that file pointer, if you remember it, we had created that file pointer by the file reserve word, and that file is static cfptr. Cf was the stands for the client file over there, and then this was ptr. We created it equal to null, and then afterwards that ptr, or that actually the pointer, had to be put over there equal to f open, and this is function is going to return it either a null, or either it's going to return something that the pointer, if it is successful over there. So that file pointer is going to be open, and this W actually suggests the mode in which that file is going to be open. This was the complete table which was encompassing the whole modes over there. The W mode is actually the most famous one, but actually it creates new file or erases the new existing files over there, which means if the file is already there, it will be erased, and then the new version will be added over there. And if you want to have an A file, which means that it's actually writing at the end of the file, and then there is the R plus mode, which is the read plus write mode, or W plus mode, which means it is read plus write, or A plus, which is read plus append mode at the end. Now, this one I told you at that time in part 1 that this is the binary file over there, and why binary files are important. Binary, as the word suggests over there, that this is going to be stored in the binary format over there. And now, why this is so, before I move on towards that very important slide which I was just showing you over just now, that is that random access file. Now, why we actually need a random access file over there? Now, previously, whenever you were storing the data, now see this very, very carefully over there in this hole over there, whenever you were updating a sequential file. Now, this I talked in the part 1 last few minutes as well, but again, revisiting this problem over there, that whenever you have a file and inside that file you have 300 void 0.00. Supposedly 300 is the number or the sequence number, and white is the name of the person, and then there's the balance over there 0.00. If you want to change this name, supposedly over there it was white, and now you have to change it to supposedly Worthington over there as shown over there, then this means that the text quantity is going to be increased. And when this text quantity is going to be increased, then you will have to move every other value which is below this. Because if I just go back on your file over there, and if you have seen that client.txt file over there, supposingly this is the file in front of you, and you want to increase, change this name from Bilal to maybe like something as Aurangzeb over there. So when this file has to be changed over there, when you are going to write down Aurangzeb over there, then that data is going to be AURANGZEB. So it's going to be larger in text length than the Bilal which was over there. So what this means actually is this, that the whole this thing and the space has to be moved forward, and then the other data which is below this is has to be moved forward. So if you have to add a data, supposedly at second, third, or somewhere in the middle of the file, the rest of the remaining data after, which is over there, and it is not of the same length, specifically text I'm talking about, because numbers are not going to be that much problematic, because this is going to be a float, this is going to be an integer number. They have a very large high maximum value or minimum value. You can easily add them if it is even unsigned or signed number over there. But the problem here becomes because of that text which is going to be added, and you want to have that text being written over there. Now, when you are actually putting this data over there, the problem is that the solution to this is this. I'm not going towards the binary file at present. The solution is this, that if you have a file just like clients.txt, you have to change this, supposedly this entry from Bilal to maybe supposing like Aurangzeb over there. So what you will do, you have to actually change this entry over there or this line over there. So you are going to copy everything which is below that entry into a new file over there and change that entry over there in this thing, add that entry over there in the new file, and then delete this old file and rename that file which we have now created over there, because that is only because the data is sequential. You cannot add Aurangzeb just over there, that you can actually say, okay, I am going to add an Aurangzeb over there and it's going to be added. Now, normally here in Macintosh or Windows, you can do that very easily, but when you have to do it a file processing from a C language or compiler point of view, then this is not practically possible. Why? Because this was Bilal previously, and Bilal was just a five-letter text or character over there. You have to replace it with an Aurangzeb, which is like something like a seven or eight text characters. Then the all other data below it has to be moved forward over there. And the only solution, as I told you just now, is this, that you have to rewrite the entire file. Now, text files, they have a variable length record. As just told you, that the names can be different lengths over there. Since here Bilal is being replaced by Aurangzeb, or maybe it can be replaced by something Sarah, maybe a smaller record or something like that. So, but on the contrary, numbers all have almost same bytes internally, because normally you're not going to have a very big number, or maybe a long int, supposedly, or maybe a very large floating point number or a double number. So numbers are not a big problem over there, but different characters when text is written is actually the problem over there. So they cannot guarantee a space for longer data. And here you are writing down a text file where you're actually putting the data in form of characters or numbers over there. So what are the steps to do it? As I just told you, copy all the records before the target to the new file. So if this was the file over there, if you have to change this supposedly over there, you are going to copy this thing, whatever is below above that, to a new file. Then the next thing, as I just told you, you are going to write the updated record to the new file, which means that this second entry is going to be copied from over there after changing this to Aurangzeb into the second file over there. And then afterwards, when you have copied it, then the remaining data, which is below that entry, that has to be copied inside the new file. Now the old file is almost no use. You can delete it, and the new file which you have created as is shown over there, then rename the new file to the old file name. So if the file name was clients.txt, supposedly you made a new file clients2.txt, starting from here, added the records, that was the record before that was going to change over there. So write the updated record to the new file, copy all the records after attachment, and then delete the old file. Now this is a very difficult and cumbersome process over there. Why? Because the text cannot be replaced over there. You can't just insert, just like in Microsoft Word you do it. You just insert something and the remaining text they goes forward over there. You can't do that over there. And the disadvantage of sorry, is this, that I must process entire file for one change, and this is very time consuming for large files. At present, maybe your data is just going to have 100 or 200 or 300 entries over there, but it's going to be very time consuming for large files over there, and it requires very much extra disk space over there. Sorry about my cough over there. So the better alternative to this solution is actually the random access file, or actually the binary file, which I'm just going to introduce now over here for you. And that binary file as is actually the main basis of the modern files which you find out inside CDs or DVDs or USBs or the hard disk, which is not sequential. Now remember, and I don't know how many of you have seen a cassette player that was from like 1970s or 80s or maybe 90s era even, that was sequential data. So if you wanted to actually go from one song to another song, you will have to fast forward or rewind the tape over there. That is actually a form of sequential data. So you have to go on, if you want to listen some song at the end of that tape over there, then you have to actually fast forward, or fast rewind over there to actually see the data, that what sequential data you want to actually access. But here, if you know that where your record is kept, if you know where your record is kept, or which means that all the records are of fixed length. Now, this is something very important. If all the records are of fixed length over there, now here in this, you can see 1, 2, 3, 4, 5, 6. We have 6 records of, you can call it 6 lines over there, basically. So you have 1, 2, 3, 6 records of each 100 length, and that is 100 bytes over there. Now here the mean of length over here is called as bytes, because byte was the main preliminary unit for data storage in computers. When the computers were having 8 bits, that was called as 1 byte. So at that time, 100 bytes was for the so the bytes was actually the main unit over there. So all the fat allocation, that is actually called as the FAT32 or FAT16 or NTFS file system, they are based on all bytes over there. Sorry. There, so what is this random access file? Now, what this means actually, that 100 bytes of one data, 100 bytes of one data, 100 bytes of one data. So this particular file now, which we have created as clients.txt, will not be now client.txt. Now, you're not going to store the data in form of 1234 space epsilon space 10000.00. Now, you are going to convert each of this data in binary and then store it. So 1, 2, 3, 4 will be converted into its binary equivalent, whatever it is, supposedly an integer. So it will be converted into its 4 bytes over there. Arsalan is actually how much? 1, 2, 3, 4, 5, 6, 7. So it's 7 characters over there. But Bilal is actually 1, 2, 3, 4, 5. Now this is actually a problem over there. So here you are going to fix that, how much characters you are going to fix for your name. Now, practically, normally, you nowadays the names are actually getting smaller and smaller over there. It's not the prehistoric times of like 1400 years back over there, when the name was like Bu Ali Sina, Ibn Talib, and all that stuff over there. So now names cannot be more than like that 10, 15 characters long, or maybe maximum 20 characters long. So you are going to fix the character length to 20. Now your data, if it comes in between characters over there, so that will be just 20 lengths over there. And this number, which is going to be float or double, if it is double, then it's going to take 8 bytes. If it's going to be float, then it's also going to take 4 bytes. So practically, your random access file or binary files are going to be taking up over there just 100 bytes or whatever, that can be different over there. 100 bytes is not fixed over there, so you are going to have 100 bytes or whatever the bytes you have fixed over there, that data over there. So the key concept is this, that you are going to have the all records of same size, example 100 bytes each. Now this, how this bytes are created, I will just tell you, because they are going to be based on some structures over there. So that structure is going to be the important thing which we're going to convert it. So it will be a same length structure every time. So file is going to be based on some structure which we have used over there. So just like train cars, if you have seen a train over there, it has those bogies or its cars over there, they have all the same length. So it's not easy to calculate any record position. So when, if all the data inside it, then it is this is going to be an integer, 4 bytes. This is going to be a character over there of 20. Each character, we know it is equal to of 4 sorry, 1 byte over there, and it's going to be 20 character array over there or something like that. So this means this is going to be 20 bytes. And then you have a float or double. So this means that 4 over here, 620 over there, 24, and then supposingly it's going to be a float number, so it's going to be again 4 bytes over there. So this means 4 plus 20 plus 4 is going to be 28 bytes of data over there in one record over there. So that the number of bytes which is going to take, it's going to be 20 over there. And if you supposedly you want to go at supposedly a position, the record number. Now here the record number is important. Now what is that record number? Now this is something which you have to actually keep into account, that what is your record number over there. So for this purpose, This structure which you are going to store inside the binary file is going to have a key, and that key over there is going to increase over there from like maybe supposedly from 0 or maybe from 1 up till whatever number. So if you have like 200 entries in your file over there, so this record number is actually going to be kept over there. So your structure which you are going to create is going to have a record number over there, and that record number multiplied by the record size, because now the record size is fixed. In our case, as I just told you, is going to be 28 bytes over there. So 28 bytes is going to be multiplied by whatever record number you want over there, and that is going to give you the position. For example, in this case, as shown in this slide, if each record is 100 bytes over there, to find record number 3, so position would be equal to 3 into 100. So this will be 300 bytes from start. So you will jump directly to byte number 300. And why this is so? Because you're not going to start from 400. Why? Because the address always starts from 0. So 0 to 100, it's going to be the first record. From 100 to 200 is going to be the second record. From 200 to 300, it's going to be the third record. So now you want to actually go on towards the third record position. So this will be 300 bytes from the start over there. So at 300 bytes, this is going to be your third record over there. So this is record 0, this is record 1, this is record 2, this is record 3. Practically, this is actually the fourth entry over there, but we are calling it as the record 3 over there. The advantage of doing this thing and having the same record size is that now you have a direct access to any record. You can update it without rewriting the entire file, and you can insert or delete without any moving any other data inside this thing over there. And what is the main common use of this file application is this: inside the banking system, you all know you have like thousands of millions of account over there. So you just know, okay, what is your account number? Based on your account number, you know what is the record size for that account over there. Multiply that account number, because of course the account numbers are going to be sequential. Multiply it, and then it's going to give you the position at which you are going to find out. Now there are going to be functions there to take your data at that particular byte or tag that particular position over there. And remember, all the data is going to be stored in binary. That's why it's called as binary, and it is going to be converted into its binary bytes over there. Again, airline reservations over there. Supposedly you have a plane. For each plane, you are going to have a file over there. So you're going to check the seat availability, the book specific seats over there. You want to take the window seats or the aisle seats, something like that. Then the point of sale system. Supposedly you are in some metro or some cash carry situation over there, or big departmental store. So if you want to find out the product over there, nowadays you have a QR code, which is actually the more fast, easy way. Previously, if you remember it, they used to enter the number. So when you had entered the number over there, it takes directly to that file inside the database over there, and it gives you the fast product lookup over there. And if you want to change the price of it, you want to maybe take the price from it or maybe update the price, or you want to update it, okay, now the quantity has gone to 0 inside the shelf over there, so you can update the inventory very easily. Similarly, database system, the same MySQL system is based on the very same thing. So you can actually record retrieval very, very fast if you know that your each record is going to be of that particular byte. So that is very simple way, or efficient updates can be done by using this random access. And this way, you don't have to sequentially process the data. Your each file is actually going to be placed based on your record size, and you already know the position by multiplying the record number by record size. Now, for this purpose over there, let me just go through the self check questions a little bit. They are from your book over there, so nothing fancy. Individual records that you write to and read from a random access file may be accessed directly without searching through other records, and this makes the random access file appropriate for systems that require rapid access to specific data. Yes, it's true. Why this is true? Because you already know your record number, and there is going to be a key. What is this key? I will just tell you little later on with an example over there. So a random access file uses fixed length records. So the exact location of a record relative to the beginning of the file can be calculated based on the same formula as I have told you, that is actually the record key. So whatever that record key, if you are talking about a banking system, the bank account number, if you're talking about maybe supposedly an inventory inside your departmental store for the product over there, the IDs over there, or something like that, or maybe the roll number or registration numbers of you students over there, just like you have it in the university over there. So based on it, you have a record size multiplied by the position, and you can easily find out the record key. Now, the two functions that you require for this purpose are called as fwrite and fread over there. And these functions are very, very simple, nothing fancy over there. If you can just see over there, fwrite. Now, this is going to be writing in the binary file. Remember, these functions are there for the binary file. They are not for the text file over there. And one thing very, very important, now the files which are going to be created, they are not going to be txt files. The file that is going to be created is going to be students.dat file. It will be something clients.dat or something like that. The extension of that file will be dat format over there. So that format, for that format over there, I will tell you how you're going to open that file and all that stuff over there. So over here,